In this lesson, we will examine three important exponent laws. The first law is called the product law. To set up this law, please consider the following example. Notice that in this product, the two bases are the same. Now to find this product, we can first rewrite 8 to the power of 5 as follows, and then rewrite 8 to the power of 2 as follows. At this point, we can combine both pieces here to get the product of 7/8, which we can now rewrite as 8 to the power of 7. So 8 to the power of 5 times 8 to the power of 2 is equal to 8 to the power of 7. Now consider this example. This time we can rewrite 2 to the power of 3 as follows, and then rewrite 2 to the power of 7 as follows. When we combine both parts here, we get the product of 10 2's, which we can now rewrite as 2 to the power of 10. So 2 to the power of 3 times 2 to the power of 7 is equal to 2 to the power of 10. We can generalize these results as follows. To find the product of x to the power of a and x to the power of b, we keep the base the same and simply add the exponents a plus b. Please note that if we want to apply the product law, the two bases must be the same. Okay, the next law is called the quotient law. Once again, we will set up this law with an example. Let's begin by rewriting the numerator as follows, and then rewriting the denominator as follows. At this point, we can eliminate 2 8's from the top and the bottom to get the product of 3 8's, which is equal to 8 to the power of 3. So 8 to the power of 5 divided by 8 to the power of 2 is equal to 8 to the power of 3. Now consider this example. Let's first rewrite the numerator here as follows, and then rewrite the denominator as follows. When we eliminate 3 2's from the top and the bottom, we get the product of 4 2's, which is equal to 2 to the power of 4. So 2 to the power of 7 divided by 2 to the power of 3 is equal to 2 to the power of 4. To generalize these results, we can say that x to the power of a divided by x to the power of b will equal x to the power of a minus b. Please note that, like the product law, the quotient law also requires that the two bases are equal. Okay, now in an earlier lesson, we learned that if we take any non-zero number and raise it to the power of 0, we get 1. We can now see why this is through the following example. Since the numerator and denominator here both have the same base of 2, we can simplify this quotient by applying the quotient law. So the quotient here will be 2 to the power of 3 minus 3, which is equal to 2 to the power of 0. Now to see why 2 to the power of 0 must equal 1, let's evaluate the same quotient in a different way. Since 2 to the power of 3 equals 8, we can rewrite our quotient as 8 over 8, which is equal to 1. So when we evaluated 2 to the power of 3 over 2 to the power of 3 one way, we got 2 to the power of 0, and when we evaluated it another way, we got 1. As such, it must be true that 2 to the power of 0 equals 1. We can generalize this result to conclude that any non-zero number raised to the power of 0 must equal 1. Okay, the last law in this lesson is the power of a power law. In this example, we are taking 5 to the power of 7 and raising it all to the power of 2. Since we are raising 5 to the power of 7 to the power of 2, we can rewrite this as the product 5 to the power of 7 times 5 to the power of 7. At this point, since we have the product of two powers, we can apply the product law to see that 5 to the power of 7 times 5 to the power of 7 equals 5 to the power of 14. So 5 to the power of 7 all to the power of 2 is equal to 5 to the power of 14. Okay, here's another example to consider. The exponent of 3 here means we can rewrite this expression as 2 to the power of 10 times 2 to the power of 10 times 2 to the power of 10. Since we have the product of powers here, we can apply the product law to see that we can combine these powers by adding the exponents to get 2 to the power of 30. So 2 to the power of 10 all to the power of 3 is equal to 2 to the power of 30. To generalize these results, we can say that x to the power of a all to the power of b will be equal to x to the power of a times b. In other words, if a power is raised to another power, we can keep the base the same and multiply the two exponents. Now, before we conclude this lesson, let's first examine some common mistakes that students sometimes make. In doing so, we can avoid making these same mistakes ourselves. Now, the first mistake is to evaluate a power by multiplying the base by the exponent. The correct way to evaluate this power is to take our 2 and multiply it by itself 5 times to get 32. Now, another common mistake is to multiply the exponents when finding the product of two powers. When multiplying powers, the product law tells us to add the exponents. Now, what do you think is a common mistake when simplifying fractions like this one? Well, the common mistake here is to apply the quotient law even though the two bases here are not the same. To apply the quotient law, the numerator and denominator must have the same base. Since this is not the case in this example, we cannot combine the numerator and denominator here. Another common mistake occurs when multiplying two powers. The mistake here is to multiply the bases. The product law tells us to keep the same base and simply add the exponents. Now, when finding the power of a power, a common mistake here is to raise one exponent to the power of the other exponent. The power of a power law tells us to keep the same base and multiply the two exponents. Another mistake is to apply the product law to questions involving addition or subtraction. It turns out that there are no nice laws for combining the sums of powers. Having said that, if we are finding the sum or difference of powers where the bases are the same, it is okay to factor the sum or difference, since doing so may be a useful strategy for some questions. Okay, let's summarize. In this lesson, we learned 3 laws for simplifying expressions involving powers, and we learned some common mistakes to avoid.